નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Hello students, today we will continue exercise 6.5. This is the topic of standard 10 chapter number 6 triangles. Question number 4. What is the question? Question is ABC is an isosceles triangle, right angle at C. Prove that AB square is equals to 2AC square. So here we have given that one of the right angle triangle which has right angle at C is also an isosceles triangle, right? And obviously if it is right angle at C, then these two sides will become equal, right? So in given section we can write down that AC is equals to BC, right? That you have to think that if two sides are equal here, obviously C is the right angle triangle, so hypotenuse is the longest side, so obviously these two sides will become equal to each other, and that things to prove here we have to prove, right? So as this is a right angle triangle, triangle ABC is right angle triangle. So according to the Pythagoras theorem, right, according to the Pythagoras theorem, we can write down that hypotenuse square, that is AB square, will become equal to BC square plus AC square, right? Okay, now what we have given that instead of AC we can put down BC, or instead of BC we can put down AC. Both are equal. So here we have to require to put AC instead of BC. So we can write down this as AB square is equals to AC square plus AC square, and therefore we can write down AB square is equals to 2 times AC square. So this is the required result. Yes, this sum is this much simple. Okay, so now let us study the question number 6. Question number 6 is ABC is an equilateral triangle of side 2A. Find each of its altitudes. Here we have given that suppose one of the triangle we are taking ABC, it is an equilateral triangle, right? And its all the sides are equal, and it is given we have that is 2A. Okay, we have to find out the altitude. So let's suppose we are taking one of the altitude, that is AD, which is perpendicular to BC, right? We have to find out the length of this altitude. We have to find out AD. So here let us, if we draw the perpendicular here, altitude here, we get here the two triangles, right? So actually we can write down the Pythagoras theorem here in triangle ABD or in triangle ACD to find out the AD, right? Because what we have to find out AD. So we can use the Pythagoras theorem in either of these triangles, but we have one of the side AC 2A. We don't have AD. Actually we have to find out it, but we don't have BD, BC. Either we do not have BD or we do not have DC. If we have either BD or DC, we can directly use the Pythagoras theorem, but we do not have anything. So first of all we have to find out the value of BD and DC. So how we can find out it? See, total length we have, that is equals to 2A. Okay, so here let us consider these two triangle ABD and ACD. So in triangle ABD and triangle ACD. See, in this two triangle we know that this is an equilateral triangle, so AB side will become equal to AC side. Reason is equal sides. One more thing we can write down that angle ADC, angle ADB, yes, ADB will become equal to angle ADC because both are of 90 degree, right? So one more thing here, we can write down that side AB is equals to AD. This side is common in both the triangle. So three conditions we have. One is the side, one is the right angle, another is the side. So if we consider triangle ABD, then AB is what? The hypotenuse. AD is one of the side of the triangle, and angle D is right angle. So according to the right angle, uh, then hypotenuse and side, that means RHS rule. According to the RHS rule, we can write down triangle ABD is congruent to triangle ACD according to the right angle and hypotenuse and side rule. Now there is a question arise in your mind that why we prove these two triangles congruent? We cannot we prove that the two triangles are similar? But what is the result we get if we prove the two triangles similar? We get the sides in the proportion. We cannot prove that the two sides are equal. But here, as we have proved that the two triangles are similar, now according to the CPCT, we can say that the BD and DC side will become equal, right? So BD will become equal to CD according to the CPCT. Right? Now we know that the total length is 2a. Total length is divided into the two parts, that is BD and DC. That is why each part get the value a. So here we can write down that BD is equals to CD, and how much it is? It is 1/2 of BC, and 1/2 of BC, that means 1/2 of 2a. 2a will cancel out, we get the a. That means BD and CD both have the same value, and that is equals to a. So what is the thing we required? Either BD or DC. Now we get the value of, that is a. Now we can apply the Pythagoras theorem. So in triangle ABD, angle D is right angle. So according to the Pythagoras theorem, now we can write down that AB square is equals to BD square plus AD square. Right? This we can write down according to the Pythagoras theorem. Now we have all the values. Whatever the value we have put down, AB is what? AB is 2a. That is 2a whole square. What is BD? BD is a square. And we want to find out the AD. Keep it as it is. Take this a square to the left hand side. See here 2a square is 4a square minus a square. That is equals to AD square. Now we will make the AD as a subject. We get the AD square is equals to 4a square minus a square, that is 3a square. Now take the square root both the side. We get the value of AD. Therefore we get the value of AD is equals to under root 3a. So this is what we required, what we want to find. In the question we have said that we have to find out the length of all the altitudes. See, this is an equilateral triangle. So all of its altitude will become equal. So all of its altitude has a length root 3a. If we draw the altitude from B onto the side AC, it also has the length root 3a. If we draw altitude from this C to on this side AB, it also has the length root 3a. So as this is an equilateral triangle, all of its altitude will become equal, right? And all of the altitudes has a length root 3a. Okay? So this is all about this lecture. Thank you. Thank you for joining us.